Yellowstone Supervolcano past eruptions. This is what caused them, and this is how we know. USGS Caldera Chronicles latest. It's a weekly article written by U.S. Geological Survey Yellowstone Volcano Observatory scientists and colleagues. August 12th issue, Yellowstone Caldera Chronicles. Contributed this week by Christy Till, Associate Professor with the School of Earth and Space Exploration at Arizona State University. As we learned in the earlier Caldera Chronicles post, volcanoes don't erupt at regular intervals or on a schedule, which is why they can't be overdue, quote unquote, for an eruption, because we never know when they will erupt. So what does cause an eruption of volcanoes like Yellowstone, which is of course a supervolcano? To answer this question, we need a black box recorder of sorts, one that can tell us the process leading up to past eruptions and how long it took. Luckily, over the past 10 to 15 years, we've developed just such a recorder, in other words, crystals, examining the crystals. That may sound surprising. How can crystals record anything, and what do they have to do with volcanoes? When volcanoes erupt, they spit out a mixture of gas, liquid magma, and crystals formed in the magma chamber. And these crystals go on to be part of the ash deposited during explosive eruptions or lava flows during less explosive ones. And these crystals in the deposits from both big and small eruptions in Yellowstone's past have concentric zones like the rings in trees. The previous Caldera Chronicles article detailed how these crystal zones can be used to determine the age of the magma. The information stored in these zones can also allow us to reconstruct the climate in the magma chamber as the crystal grew. Specifically, they tell us about changes in the temperature, the pressure, and the chemistry over time leading up to past eruptions. The youngest zones, those at the outer edge of the crystal, tell us what was happening in the magma chamber immediately before the eruption. So what have we learned from looking at these crystal recorders? There are a number of different processes in the magmatic system below volcanoes that can cause an eruption, such as the movement of magma from a deeper storage region in the shallowest one below the volcano, or the mixing of two different kinds of magma. The crystals in deposit from Yellowstone's last big eruption about 630,000 years ago, the Lava Creek Tuff, and also in lava flows erupted about 256,000 years ago. Okay, this is the first time I'm learning of an eruption 256,000 years ago. Every once in a while, we get new information from USGS as to when the eruptions took place. We know that there was a big one, a super eruption 2.1 million years ago, 1.3 million years ago, 630,000 years ago. Now we have one at 256,000 years ago. The one at 630 was actually a double eruption about 150,000 years apart. Then we had another eruption 130,000 years ago. Then we had a major eruption 70,000 years ago, and we had 80 eruptions since 70,000 years ago. So we did have a number of eruptions. And now, so we said also the lava flows erupted about 256,000 years ago. Both tell us that the movement of magma from a deeper storage region to a shallower one created sufficient pressure to cause an eruption. And based on how seismic waves travel, we know that Yellowstone's magma system extends from the base of the Earth's crust to the surface, of course. So this movement of magma from a deeper storage area to shallow is not at all surprising. In both cases, the explosion and the lava flow, it took several decades between the time the crystals first recorded the magma movement to the eruption. This is not the end of the story, but rather just the beginning. More data are needed to confirm these results. For example, these types of studies will be done on many of the eruptions from Yellowstone's past to make sure the results are consistent. But just from these two eruptions, one big and one small, it seems that there is a common process that causes Yellowstone's eruptions. So if Yellowstone were to erupt again, which it may never do, mind you, it is possible that the eruption could be caused by a similar movement of magma from deeper in the crust to the shallowest magma chamber. This is something that would be easy to detect, such a movement of magma would cause major earthquake swarms, of course, much different and more vigorous than what we're seeing normally. Significant ground deformation and far greater than the few inches per year or uplift or subsidence that are typical, and potentially even changes in gas and thermal emissions. These parameters are well monitored, so there will be ample warning if any potential future eruption is about to take place. This work is a good example of how geological investigations of volcanoes can help us understand what has happened in the past and what might happen in the future, and how volcano monitoring systems can be tuned to best detect the lead up to such an eruption. Now, it's been 60 years since the 1959 magnitude 7.3 Hebgen Lake earthquake. Its history and effects on Yellowstone region. It occurred August 17, 1959, 11:37 in the evening, at night, and it seems appropriate to discuss the effects of this earthquake on the region and what we might expect if a similar size event happens in the future. The geologists did tell us that they do expect a large quake in this area of this magnitude. First, let's talk about the earthquake itself. The official magnitude of the earthquake, 7.3, located just outside of the western boundary of the national park. Hebgen Lake is, of course, part of the supervolcano. Now, Yellowstone Lake is a big blue body of water in number 6 that you see here. And on the left-hand side, you see something like an inverted Z. That is Hebgen Lake, just northwest of the boundary. It's basically in Montana, above the Idaho border. That's Hebgen Lake, part of course, the supervolcano. It was 6.5 miles west-northwest of West Yellowstone in Montana. The earthquake caused fatalities. It was the most of the result of a large landslide that was triggered in the Madison Canyon. Landslide carried 50 million cubic yards of rock, mud, and debris down the south side of the canyon and halfway up the north side, partially burying the Rock Creek campground on valley floor. The landslide also dammed the Madison River, causing water to back up behind it, creating Earthquake Lake. The combination of landslide, fault scarps, and damaged highways trapped tourists in the canyon that night. In addition, sudden northward tilting of the basin caused Hebgen Lake to slosh back and forth. This is referred to as Sage wave. The waves were so large that they breached the Hebgen Lake Dam a few times, leading panicked tourists to think the dam had failed. Luckily, the dam did not fail, and the waves eventually died off. The earthquake caused up to 18 to 20 feet of offset on the surface, fault scarps, and that can still be seen today on both the Hebgen Lake and Red Canyon faults, to a lesser extent the Madison Fault. And within nearby Yellowstone National Park, many rock slides blocked the roadways, and there was damage to the world-famous Old Faithful Inn, where a large rock chimney collapsed. But maybe even more spectacular were the effects of the earthquake on the hydrothermal features in Yellowstone. By the day after the earthquake, at least 289 springs in the geyser basins of the Firehole River had erupted as geysers. So the springs became geysers. Of these, 160 were springs with no previous record of eruption. At least 590 springs have become turbid. During the first few days after the earthquake, most springs began to clear, but several years passed before clearing was generally complete. So they were muddied waters. In addition, New hot ground soon developed in some places, and this became more apparent by the following spring with the formation of new fractures in sinter and linear zones of dead or dying trees. Some new fractures developed locally into fumaroles, and a few of those evolved into hot springs and even geysers. Two of the most spectacular changes were the formation of the Seismic geyser and changes to Sapphire Pool. Seismic geyser, located in the Upper Geyser Basin, started out as a newly formed fracture after Hebgen Lake earthquake, and the fracture slowly evolved into a fumarole, growing in size, and in about 2.5 years it evolved into a small geyser. A few years later it had changed into a very vigorous geyser that erupted to heights up to 50 feet and excavated a vent with a maximum diameter of 40 feet and more than 20 feet deep. In 1971, major eruption seized Seismic geyser as activity shifted to a new small satellite crater that formed nearby that. Prior to Hebgen Lake earthquakes, Sapphire Pool, located in Biscuit Basin, erupted about every 17 to 20 minutes to a height of 3 to 6 feet, and after the earthquake and until September 5th, it surged 6 to 8 feet height constantly. On September 5th, its steady boiling and surging became periodic, and the spring changed to a major geyser. Its eruptions were quite regular, occurring about every 2 hours, and were massive and spectacular. Some bursts 150 feet and 200 feet across. From September 14 to 29, it reverted to a steady surging cauldron, and on September 29 again became a major geyser, and this activity persisted until 1968. Sapphire Pool today is still a crystal clear blue water pool, and it still violently boils and surges on occasion. For the first few days after the earthquake, Old Faithful was observed to be more erratic than usual, with successive longer, shorter intervals between eruptions, and that had been observed prior to the earthquake as well. The average eruption interval the summer prior to the earthquake was 61.8 minutes, the shortest seasonal average on the record, and by September 1st it increased to 62.1 minutes, 255 eruptions intervals timed during the last 10 days of December showed an average of 67.4 minutes. Old Faithful's eruptions interval has continued to increase since that time and is now averaged 93 minutes. Now, was this a direct result of Hebgen Lake earthquakes? Hebgen Lake earthquake continues to be the largest earthquake to occur in the U.S. Intermountain West in historic times. As we approach the 60th anniversary of the event, we should remind ourselves that the area around Yellowstone and much of the western U.S. is earthquake country. Earthquakes happen nearly every day in the region, and occasionally the area produces strong earthquakes that are capable of affecting large areas and causing damage, and we should expect similar effects if another earthquake of this size would happen today. Except there are many more people visiting the area today than there were in the summer of 1959. So we have to be prepared for earthquakes. Now, we've had various earthquakes in the Yellowstone area, 4.2 in Montana yesterday, and 3.5 south of Yellowstone Lake. The 3.5 was the biggest since 2017, and the 4.2 in Montana is in an area of an earthquake swarm, and unfortunately we see that there is an increase in earthquakes, and also the intensity of the earthquakes is increasing. We've even seen that we've had very unusual earthquakes north of Yellowstone, northeast of Yellowstone, in Saskatchewan in Canada, near Manitoba, across the border, and also the fact that we've had a number of earthquakes. We just had one today, of 4.1 in South Hutchinson, Kansas, and this is at a depth of 5 kilometers. Now, there is fracking going on there, but the magnitude of these earthquakes is getting bigger, and there's a bigger swarm. Now, they can't all be fracking earthquakes, and if there was such a big earthquake swarm, and such an increase in the intensity, then they should stop the fracking. Something's going on there. And let me also remind you that this area stretching from Seattle through, from Puget Sound into Seattle, all the way into the area of Yellowstone, through Kansas, all the way down to New Madrid, is this large fracture zone, as you can see here. It's not 1,700 miles, actually over 2,200 miles, and it stretches all the way down there to New Madrid, and then it reaches another fault line, the New Madrid fracture seismic zone, which is actually a rift valley going, it's a real foot valley going all the way up to the St. Lawrence River in Canada, opening up into the St. Lawrence Seaway. That's where it intersects, right there in New Madrid. And that's where we have a crisscrossing of earthquakes that we have seen an increase of recently. And we have, of course, Hutchinson, Kansas is exactly right there in the middle. The hazard, little red hazard sign that you see there in New Madrid, that's the crack. You can even see it very clearly right there on Google Earth. And that's New Madrid, that hazard zone size. That's where the two Mississippi River, we even have volcanoes down there, all the way up to Ottawa, Montreal, through, we measured it. It's over 1,800. It's about 2,200 miles, actually. So perhaps that's why we're seeing a connection, that we have Yellowstone earthquakes, we have New Madrid earthquakes, Kansas earthquakes a few hours from each other, because of the fact that they're on the same fracture zone right there, right there. You can see it right on the map. I will try and find for each state what the fracture zones are, because if I try and find for the continental US, I'm having a difficulty finding it. But I don't even know if they've mapped all the fractures in the United States yet, really. I doubt that they've mapped all of Yellowstone's. But usually where we see rivers, we have, those are fracture zones, okay? But that there you can very clearly see. And that's the New Madrid right there, New Madrid, and Mississippi River. That is all that there is a rift valley, and it heads up through Ottawa, Montreal, and out the St. Lawrence River Seaway. And okay, so we're having, it seems, an increase in seismic activity having to do with Yellowstone, having to do with the West. And I'll just remind you that in the past, in 1999, we had a 7.1 Ridgecrest earthquake, which gave Yellowstone an earthquake swarm. The same thing with the Alaska earthquake, the 8.8 magnitude Chile earthquake, and the Haiti earthquake. They all gave Yellowstone earthquake swarms a couple of weeks after their earthquakes hit. How is that possible? Well, we don't know. We don't know if perhaps there's a magma plume that connects all these areas. We have no idea yet, but we know that Yellowstone is affected. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition, and the community around our church. Thank you.